Hi guys, this is my first video on buffer overflow. Hope you can hear me properly. I'm sorry about the background noise. Yeah, so like I say, this is my first video on buffer overflow. I've been studying to write my OSCP exam, offensive security penetration tester. Offensive security certified professional. Yeah, that's the one. Yeah, so I've learned about that certification about a year ago now, and I've been reading a lot on security and all that, and I kind of like that whole space, the whole security thing. So what I've done is I started with my CEH, Certified Ethical Hacker, which I studied for about a month and wrote my exam, and yeah, eventually the exam went well, and I got my certification, and yeah. But CH is good. But there's just a lot of theory, on it, and I'm really a hands-on type of guy. So, my idea career right now is really to do penetration testing and so forth. So yeah, that's why I'm eyeing for OSCP. So enough about that. Yeah, so I've been through the OSCP material. Well, the whole material actually, and I'm pretty okay with most of the material. The one area that's been bothering me has been buffer overflows. Buffer overflow has been really it's been a really daunting area, to work on. When you look at all those hexadecimal numbers and binary code and so forth. And it looks quite scary, but then I had to take the challenge, so I took it on after my CEH exam. Spent about 2 weeks trying to understand how this buffer overflow works, and yeah, run about the second week, I started getting an idea, which is kind of now. So I started getting an idea of what was really going on, in a buffer overflow, understanding the memory structure. One of the most important things is understanding the memory structure, understanding the memory layout, understanding how a program loads into memory, and how data is read, in the memory. So in that, you need to understand register. You need to understand what registers are. What a stack is. You've got a heap. You've got a heap as well. But we're not really going to talk about a heap because we'll focus on the stack, overflow. So basically, what is a stack? A stack is an allocated space in memory. So for every program that you run, it's especially a program that requires input, that requires input, so it needs to store those inputs somewhere, and it stores them in a stack, as variables. Okay, so a stack is an allocated space in memory for a specific program, which will hold values in there, so that will be a variable. What in a buffer overflow, what happens is that you basically overflows that allocated space. So if you've been allocated 15 bytes, if you write if you write a value that is beyond 15 bytes, then buffer overflow occurs. So on a high level view, that's pretty much what's happening. But I'm just going to take you quickly through through a little bit of a detailed view that I just done, before we actually go through an actual an actual example on Linux. Alright, so let's go through here. You know, put it, this will be here. That's the file. Okay. Now, okay, this is what I've compiled. Alright, so what you're looking at, this is basically a memory layout. Okay. Memory layout including your stack. You know, then you've got portion of the rest of the memory. Okay, so now this is the word hello. Okay, you've got E-L, H-E-L-L and O. Okay, so let's take, okay, let me first show you. Let's take an example of a code that we'll use. We'll use this code here on you know, it's stack buffer overflow Wikipedia page. Now this is a C code which got a buffer overflow vulnerability. And so basically what's happening here is that you've got a function, right, that get defined here. This function will contain characters, and in that buffer we will allocate 12 bytes. Okay, we'll allocate 12 bytes of buffer basically, so 12 bytes of character, okay, that we want allocated. And then what this function does is that it copies the input of the user to the buffer. So it copies bar, which is the input of the user, to C, which is the buffer. Alright, and then this is where it actually gets called. It gets defined, and then it gets included into the main function. There it is here. This is the function, that's the first argument that it will read. So basically here we're saying 12. So when we go back to our layout, so we say okay. So if we write this thing with hello, it's okay because it's still under 12 bytes. So the program will run, you know, successfully without any problem. Now look what happens next, you know, when we actually try to do a buffer overflow. Alright, so this is the next page. Now this is the page which shows you the buffer overflow. So you've got hello, okay, up until O, and then you've got now random letters that you know, that you edit on the buffer. Okay, so we go A, okay, and then let's have a look again here. Okay, up until here, and then you've got your EBP base pointer. Not really gonna get into that now, but okay. At this point, because this is an allocated, you know, this is an allocated space as well in memory. And once you override this, okay, once you override the EBP value, you're already out of your allocated space. Because okay, so here we would have had 12 here, okay. That's my mistake. We would have 12 byte here, and then from here we're actually starting to override, because this is the EBP. So once you start putting, you know, things here, then you know, the program won't know where the EBP address is, and it will give you segmentation fault. Okay. So now here we have overwritten that, and then we carry on. As you can see at the red section, we actually now overwriting the return address, the EIP. EIP is the return address. Now the way programs works, or C program works, is that before it executes a code, it needs to allocate a return address, you know, to come back to. And the return address initially, okay, was set up to here, but now we are overwriting it with B. So when we write our code up until, okay, right up until here, or even, yeah, it's up until here, it won't know where to come back because it doesn't know about the memory address of these new characters that we put up. So the program will automatically crash from this point on. From this point on, you have overflow on the stack. Let's look at the third picture. Now the third picture, what we want to do, we want to get the memory address at this point here of the stack. So we want to get the memory address of the stack at this point, because that is a valid memory. Yeah, it's a valid memory address. It's a valid address in memory. Sorry. So yeah, so we want to get this value here. So we'll get that value, because then what we'll say okay, write all these characters, and then go back to a valid address, okay, so the program doesn't crash, and then we're going to output more data. Now this is the fourth one. The fourth one, we're saying give us all of this. Now this is the memory address that we got earlier. It's a valid address, okay, so it will come back here and valid, and then we want to print some more data. Now x90, these are NOPs. It stands for no operation. So basically, the CPU won't do anything here. It's NOPs. It's no operation. Now we want to print enough no operations here, so we can get another valid address, okay, at this point here. Let's have a look at the fifth one. The fifth one, we're saying okay, this is our stack, this is the address that we had, and then we want to get the memory address of here, okay. Now on the sixth picture, what we'll say, we'll print all these characters, and then we use the new return address that we got from here. We're gonna say, when we finish running our code, we want you to return to this valid address, yeah, which will point somewhere there, and then we've got our shell code to execute here. So what's gonna happen? This will get read. The return address will be allocated or pointed, and then we'll run no operations up until this no operation gets to our code, and then we'll return. So our code will get executed, and then we'll have a valid address to execute to, and the buffer overflow has occurred. But most importantly, we are able to execute a code here. Now this code can be can be a terminal, because if you want a terminal on the machine, so on Linux that will be a bash shell, on Windows that will be your CMD command prompt terminal, okay. So yeah, that's basically how it looks like. Now let's have a look at the actual code. All right, let me just pause this one.